All right, so let's take a look at the most common type of stoichiometry calculation, which is going to be a mass-to-mass problem. The reason why that's the most common is that in the lab, you can measure quantities with a balance. So you're going to be measuring in grams most frequently. So basically what we're doing is we're going from the mass of the substance to moles. Then we'll convert from moles of one substance to moles of the other substance. And then we'll convert back from moles of the other substance to mass. So we're still using the mole map, just in a little bit different way. What your train tracks will look like is you'll start with your known number of grams and then do the molar mass of the first substance, do the mole-to-mole ratio of moles of substance A to moles of substance B, and then the molar mass of substance B to get back to the number of grams. So I'll give you an example of that with this first example here that says calculate the mass of hydrochloric acid needed to react with 10 grams of zinc. So unknown here, we are solving for the mass of hydrochloric acid. The known, what do they give us? 10 grams of zinc. So our plan, is a chemical reaction taking place here? Yes, because we start with zinc and we end up with, we're not ending up with hydrochloric acid, but we need to know how much hydrochloric acid will react with this amount of zinc. So that's a stoichiometry problem. When you start with one substance and you calculate the amount of another substance. Well, if there's a chemical reaction, do we need to write the chemical reaction before we can do anything else?
Yes.
Yes. So our first part of the plan is going to be to write the reaction. All right, so after we figure out how many grams, or after we figure out the reaction, then we're going to convert our grams of zinc to moles of zinc. And then we're going to convert moles of zinc to moles of HCl.
Can you zoom in a little bit?
Sure. All right, and then since they asked us mass, then we'll have to convert back to grams of HCl. All right, and that's really it as far as the work that we're going to have to do. So let me show you that. Let's write the reaction first. So we've got hydrochloric acid and zinc, and there. See how it says they react with. So if it's with it, it's on the same side of the reaction. So it's going to be HCl plus Zn. And hopefully you remember that that's a single replacement. So it's going to form zinc chloride. The zinc replaces the hydrogen. And hydrogen gas. And then, can I slide over to the other side now? Okay. All right. So is this balanced? No. So I need to balance it. So I'm going to put 2 there. And that's it. So that's the reaction. Now, what's the ratio of hydrochloric acid to zinc? It's 2 to 1. That's going to be important in just a moment. So let's follow through with the rest of our plan here. So we're going to start with our known number of grams. So we're going to start with the 10 grams of zinc. Now, it is very important that you write the unit and the identity of the substance for stoichiometry. You will be confused the entire time if you do not do both of those. And if you are a sloppy writer, write neatly. Because if you write sloppily, you will also be confused, more than likely. It's another one of those previous experience things talking here. All right, so what's the molar mass of zinc? How do we convert from grams of zinc to moles of zinc? Yeah, sure, 65.4, 65.38. All right, so the 65.38 grams of zinc equals 1 mole of zinc. So this is going to remove the grams of zinc. Now we have moles of zinc. Our next step is to convert from moles of zinc to moles of hydrochloric acid. Now, we know that for every 1 mole of zinc, that there are 2 moles of hydrochloric acid. So we're going to use these coefficients from the balanced chemical equation to make this next conversion. Right. And again, that's the only new thing that we're doing in this unit. Okay. So if you're like, hey, where did this stuff come from? I'm going to highlight it for you because this is the important part. The other stuff, hopefully you remember where that comes from. Wow, the highlighter really washed that out on the screen. Anyways. Okay. So the balanced chemical reaction gives us the coefficients for this conversion. Now, do the moles of zinc, does that unit cancel out? Moles of zinc, moles of zinc. Yeah, sure. So let's cancel that out. And then we got one more step to get to what they asked. They asked us for mass. We're currently at moles of hydrochloric acid. So again, if we're at moles and we need to get to mass, then what conversion do we use? Yeah, use molar mass. Okay, is it still 65.38? Why not? It's not the same thing. Zinc was 65.38. Hydrochloric acid, what is it, 36.5? Or so. 36.45. You want to go a little more specific? 36.461. Okay, if you use 36, if you use 36.5, I would have probably been okay with it. But yeah, let's go with that. All right. So, anyways, now we can cancel out the units, moles of HCl. Notice I didn't cross out any numbers here. So when you put this in your calculator, you can omit the ones, but we're going to multiply 10 times 2 times 36.461, and then divide by 65.38. And again, you can just omit the ones because they don't change the value. This is what now? 11 point. So 11.2 maybe, because to the right number of significant figures, it should be 3. So 11.2 grams of HCl. And just kind of as just a little check for us, does that at least seem like a reasonable amount of something to use in a reaction with 10 grams of something else? Yeah, sure. I mean, it's harder to guess on these, but if you got like 1,000 grams, you're probably like, that's probably too much. So, that's one way you can just kind of stop and check your answer for just a moment. All right. Are y'all ready to try one on your own, or do you want me to work out the next one? You want to try the next one? Okay. All right. So go ahead and give the next one a try, and then we'll go over it.